Hi guys, welcome to this video. This is Dr. Moorthi, working as assistant professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So this is a lecture series of engineering mechanics. So in this video, we are going to discuss about a topic called displacements, velocity, acceleration, and its relationship. So in this video, we will discuss about what is displacement, velocity, acceleration, and what are the relationship between these three components. So first, uh, so this is comes under the category of dynamics of particle. Already we know that we have discussed in the previous videos about what is statics, dynamics, what is kinematics and kinetics. So dynamics is a part of engineering mechanics to analyze the behavior of any object when it is in moving condition or in motion. Likewise, the dynamics is further classified into two category called kinematics and kinetics, whereas both these two branches of studying the object in motion, and it depends on the consideration of force and without consideration of forces. So based on this, we have two classifications called kinematics and kinetics. So first, kinematics, it is a description of motion, like position, velocity, acceleration and time, without considering the force that creates the motion of particle. And the dynamics is, as I said earlier, is the combination of kinematics and kinetics. And kinetics is same description of motion, but with considering the force that cause the motion. So that is the quantity of force is acting on the object, and based on the force, they we have an effect. Yes, this is the first, the distance and the displacement. So the distance is a scalar quantity, describe how much the ground an object has covered. So that is the distance is covered by the object during its motion, whereas displacement is the vector quantity. It is it have both magnitude and direction, how far out of place an object is change its position, that is initial position and final position. And next, we have here we have the diagram called cover the 12 meter distance is covered by the object, and whereas in the direction, lengthwise we have 4 meter, and and height wise we have 2 meter. So 4 and uh, 2 4 meter plus 2 meter and plus 4 and likewise 2 meters. So totally we have 4 plus 4 8, and one more 2 plus 2, so 12 meter distance the object covered. And whereas the displacement, as I said earlier, the final distance minus initial distance, or you can take it as a position, final position minus initial position. Object is moving in the direction, the clockwise direction, and finally it is comes into the original position. So there is a no displacement. So here the displacement will be 0. And speed and vector, whereas speed, as I said earlier, speed is a scalar quantity, and whereas the how fast an object is moving, and it doesn't depends on the direction which the man is moving, or like that. And where velocity is the vector quantity, as I said earlier, and it depends on the position or direction in which the object is moving. If you take the upward direction, the velocity, the object moving in the same mass, and you can take it as in the downward direction. So whereas the distance covered by the object is varying, that depends on the time taken. Yes, here the average speed is equal to distance traveled to the total time of travel. So if you, for example, an example, if you take, the train is moving from one station to another station, so in between that we have a number of stages, so that the for that each time between the station 1 and station 2, and station 2 to 3, and likewise 3 to 4. So there is an different distance and different time taken. So that if you take an average speed, you can take it as a total distance start to end and divided by total time taken by the train to cover this entire distance, so you will get the average speed. Similarly, the average velocity, that the displaced total displacement divided by the time taken. So likewise you will get the what is the average speed, average velocity. So as we know that the change of displacement is velocity, or the first order differentiation of displacement is velocity, and then the second order the differentiation of displacement is acceleration. As I said earlier here, the acceleration is similar to velocity. It is a vector quantity. It depends on the direction. So and based on the direction the value will be differ. So this acceleration is the second order differentiation of displacement, or first order differentiation of velocity. You can get the acceleration. Thank you.